Dear students, in this video lecture, I am going to explain how to solve a cantilever truss by using the method of joint. The numerical I have taken to solve the numerical by joint method is find the support reactions and force in all members of the truss shown in the figure. E is the midpoint of AD. The truss is given as, this truss is fixed at the base AB and the members are used to support the load 1.5 kilonewton, and this 1.5 kilonewton is attached at point D. Now this is the free body diagram of this truss. One data you can observe in this question, it is asked specifically to find out the support reaction for the cantilever truss. In the previous lecture, I explained about the cantilever truss, and in that I told you that when cantilever truss is asked to analyze, then do not solve it with the support reactions. But in this case, the support reactions are asked. It means that the four support reactions, we have to assume the points where the truss is cantilevered or fixed. At point B and at point A it is fixed, so we can say that at point B there are two support reactions, at point A two support reactions, and the loads as it is. One data you can observe in the question, it is given as E is the midpoint of the line AD. AD line, for that E is the midpoint, that's why EA and ED is having equal distance. I have assumed that it is X, and the total length of the AD I have assumed as 2x, and the angle for the line AD is as 50 degree with x-axis. That's why by considering this as hypotenuse, I have formed this triangle and I have given this height as 2x sine 50 and this base is 2x cos 50. Now I have find out the distance at this place as BA, and this distance BA I find out by using this AC height as constant equals to 2x sine 50. And with this case, I know the angle, I know the opposite side of this triangle, opposite side of this angle. So in that triangle we can apply tan theta opposite upon adjacent. So we can find out this adjacent side also by using the tan theta. So tan 60 is equals to length AC upon length BA. So length BA is equals to 0.884 times of x. With this data, I can say that we can find out the length of the given distances in the truss. So now with this case, I have started with the solution of all the members in the truss first. Now I said as in case of the cantilever truss, let us start to solve the force. Let us start to find out the force in the members of the truss first. So now in this case, select the joint D, at which I found as two unknown members are, that is DE and DC. 1.5 kilonewton is known, so I have selected D joint and I have started with that. So I have applied summation Fy condition at this point first. So I got the FDE magnitude as minus 1.958 kilonewton. Minus sign indicates that the assumption initially I have made as the member is tension, the member with the tensile nature. So answer comes as minus, it means it is a compression. Now DE I have substituted in the equation summation Fx. As minus of this minus become plus, so then the equation will be FDC is equals to plus 1.958 times of cos 50, and that become equals to 1.258 kilonewton. Answer positive, it is tension. Answer negative, it is compression. Then I have selected point E. As I select the point E, I can see at point E there is a T joint. We can say FEA is in tension, ED is in tension, EC is in tension. Three members at a joint E. Out of them, Two are collinear, one passing from them. Third force, which is passing from the E point, it is non-collinear, so that non-collinear EC is 0. That's why by observation I have mentioned it is as 0 force member. Then at a joint E, there are only two forces. To keep the joint E in equilibrium, we should mention this point that FED and EA should have equal magnitude and opposite direction. So that's why FED and FEA with same magnitude. As ED we know that it is minus 1.958 kilonewton, as it will be equals to EA with compression. Then I have selected the joint C. At point C there are four members. As assuming tension, the members will be C, D, C, E, C, A and C, B. So with this case I have drawn the free body diagram of joint C, and I have found out the magnitude of BC or CB. It is 2.517 kilonewton, and it is positive, it means it is in tension. Then by substituting it in equation of summation Fy equals to 0, then the FCA equals to minus 2.18 kilonewton. As we solve all the members with their magnitude and nature, now it is time to find out the support reactions. Let us start to find out the support reactions. How? So while defining summation Fx condition by considering entire truss, I have selected the entire truss and I have applied summation Fx condition. In that, summation of Fx equals to 0, Bx plus Ax equals to 0, Bx equals to minus Ax. With this case, I can say that the equation as Bx will having same magnitude of Ax, but it should be in opposite direction to Bx. And I said that unknown equation equals to 1. Then I have applied moment at point A. As I applied moment at point A, I got the equation as By equals to minus 2.182 kilonewton. The dimension are defined. At point A I took moment, so 1.5, horizontal distance is 1.286x, and for the By, the horizontal distance is 0.884x. So with this case, x will be cancelled, and with that By magnitude will be minus 2.182 kilonewton. By we have assumed upward, answer will be minus. It means that the direction is downward of this By at point B. Then summation Fy if I apply, so then I got the answer as Ay 3.682 kilonewton. Positive answer, assumption is correct, it is in upward direction only. As I find By and Ay, so I can find out at point B this as Bx, because BC as or CB as I know that it in magnitude and nature, so we can find out Bx at point B by selecting the joint B. I have selected the point B and I have drawn the free body diagram of this joint B. FBC with that two components, and Bx is along x direction, By in upward. I have taken this as upward only because I have to use this By with minus sign. Okay, so now with this case I can say that the component of B of FBC cos 60 plus Bx is equals to 0. With that Bx comes as minus 1.258 kilonewton. Minus sign indicates that it is acting towards the left direction at point B. So as you know that Bx equals to minus Ax. So Bx is leftward, so then Ax will be rightward. That's why 1.258 rightward direction positive. Now as Ax and Bx we know that By and Ay also know that, so then we can find out the resultant reaction at point B and A. So Ay and Ax, with that we can Ra in under root Ax square plus Ay square and its equation, and by substituting these values of Ax, B and Ay in equation of this resultant, we have found out this magnitude of resultant is 3.891 kilonewton. As at point A, Ax is positive, Ay is also positive, it means the resultant is of first quadrant. with an angle theta A with x-axis. So theta A is 71.13. As RB, for that root of bx square plus by square. As the answer bx and ax in under root, so we can take this as square and addition, so then with that case its magnitude is 2.518 kilonewton. As bx in leftward, by in downward, with that case we can say that the angle of this resultant RB with the x-axis, negative x-axis, it is theta b, it is 60.03 degree. So with this case I can say that the correct magnitude and nature of the member we can mention DC plus sign means tension, DE 1.958 with negative sign compression, EA with negative sign 1.958 as compression, then EC is 0 magnitude, that's why there is no nature, then CA is 2.18 with minus answer, it is compression, CB it is with plus answer 2.517, it is tensile in nature. So with this manner we can solve this numerical, that is the numerical of cantilever truss with support reactions by using method of joint. I hope you clear the numerical with its concept as well as the sign conventions that we have to adopt throughout the solution of this cantilever truss or any kind of truss. Thank you so much.